In this video, we will graph the cosine function and identify its parameters. Let's begin with what we already know. We know that one of the sinusoidal function is the sine function. We create some special radian measures to evaluate for sine theta to understand the shape of the graph. We use the unit circle to show the sine parent function. We know that one cycle around the unit circle is 360 degrees, or 2 pi. That is also known as the period. And we will look from 0 to 2 pi and divide it into quarter periods. So we'll have 0, pi over 2, which is also equal to 90 degrees, pi, which is also equal to 180 degrees, 3 pi over 2, which is also equal to 270 degrees, and then 2 pi, which is also equal to 360 degrees. So let's put this in a table of values given the special radian measures of the angle 0, pi over 2, pi, 3 pi over 2, and 2 pi. And then we will identify the y values for sine. So keep in mind, to evaluate for the sine values, we are looking at the y values. So let's begin. When our theta is equivalent to 0 in our unit circle, then the y value is going to be 0. We will plot that point in our coordinate grid. 0, 0 is at the origin. When our angle is pi over 2, then the y value is 1. We plot the points pi over 2, 1 in our coordinate grid. When our angle is pi, then the y value is 0. So plotting the point pi, 0 in our coordinate grid is right here. And then if our angle is 3 pi over 2, then the y value is -1, and then we plot that in our coordinate grid. And if our angle completing the one full rotation, 2 pi will back at 0 y value. So we plot the point 2 pi, 0 in our coordinate. So when connecting the points, the graph of the sine function would look like this. Please note that the function starts at the origin. The sine function starts at the origin and will oscillate on the other side of the x-axis. Now let's take a look at the cosine function. We will do the same thing. We will choose some special radian measures to evaluate for cosine theta to understand the shape of the graph. So same thing, one cycle around the unit circle is 2 pi. We will divide it into quarter periods, so we'll also have the 0, pi over 2, the pi, 3 pi over 2, and to 2 pi. But this time, because our function is a cosine, we will be looking at the x values in our unit circle. So we're referring to these values in those special points. So when our theta is 0, our x value is going to be equal to +1, and we plot that point in our coordinate grid, 0, 1. When our angle is pi over 2, the x value is 0, plotting that point in our coordinate grid. When our angle is pi, the x value is -1, so we plot that also in our grid. And when our angle is 3 pi over 2, the x value is 0. And when the angle is 2 pi, we're back at x value equal to 1, and we plot that point in our grid. Now, connecting the points, the graph of the cosine parent function would look like this. Please note that cosine function starts at the maximum and sometimes minimum. and will also oscillate on the other side of the x-axis. Now that we know what the parent function would look like for sine and cosine, let's take a look at how this function should be written. So sinusoidal function can be written in these forms. For sine, we will use y equals a times sine bx plus d. For cosine, y equals a cosine bx plus d. If you notice, the two equations are almost identical. Their only difference is the function itself. So in this equation, a represents the amplitude or the height of each wave above or below the midline, as you can see in this animation. And then b represents the period or the frequency, or how many cycles occur within 2 pi. We can manipulate this when we know our period, and if we were looking for the value of b, we can manipulate this 2 pi over b. And the d stands for the midline. We know to calculate for the midline, we'll use maximum plus the minimum, then divided by 2. Now let's have an example. Given the graph of the cosine function on the right, let's identify the map, or the midline, the amplitude, and the period. To identify the midline, we will add the maximum and minimum values, then divided by 2. So in this case, since the midline, we're referring to the y value that is in the middle of the maximum and the minimum. In this case, the maximum is at 4 and the minimum is at -2. So we'll add 4 plus -2 divided by 2. We'll have 2 over 2, which is equal to 1. So our midline is at y equals 1. For the amplitude, the height of each wave from the midline, in this case, from the midline to the maximum or the midline to the minimum, will have 3 units. Remember, amplitudes are always the same and always be positive. So we'll put 3 or 3 units. And for the period, we can use maximum to maximum. So we'll have 0 and then 2 pi. So we'll have 2 pi minus 0. And because period is how long does it take to have one full cycle. So from maximum to the maximum, we have 2 pi as our period. Now, in this case, let's write a cosine equation for the graph below. So keeping in mind how the function should be written, y equals a cosine bx plus d. We're gonna find the map, or the midline, amplitude, and period in that order. So given this graph, let's first determine the midline. So maximum plus minimum divided by 2, and then we'll replace the d in our equation once we find the value from the graph. So the maximum here is 2, and then the minimum is -4. So 2 plus -4 divided by 2 is equivalent to -1. So our midline is -1, and we will replace that in our equation, the d in our equation. And then step 2, let's determine the amplitude of the waves by calculating the distance from the midline to the maximum or minimum value, and then we will replace the a in the equation. Again, the amplitude is never negative, okay? So -1, because that's our midline, we count from that point to the maximum, which is 2, and we will know that that's going to be 3 units. So our a is going to be 3, so we'll replace that in our equation. Meanwhile, for the b, we determine the period and plug it into the formula. To solve for b, we can manipulate the 2 pi over b, and we will place that in our equation. So in this case, we can use the maximum and maximum. So we have 0, we're referring to the x-axis, so 0 to right here 6 pi, so we have 6 pi minus 0. So our period is 6 pi. So manipulating our formula earlier, the 2 pi over b, to calculate for b, we can switch the b and the period. So since we know our period is 6 pi, we can replace that, and then we can simplify by canceling out the pi's, and we'll have b equals 1/3. And we will use this value of b to replace in our equation 1/3. So our equation will be y equals 3 cosine 1/3 x plus -1, or you can just drop the plus and just put -1. So this is our equation for this given graph.